No, but thank you. So it came from observations of supernovae, go away, dyslexia, supernovae. There we go. I like how I get that part right, but I can't get the B and the P stuff mixed. I keep flip a B instead of a B. Anyway, so it came from observations of supernovae. What we noticed is that they came towards us or expanded away from us, depending on our perspective, at increasing rates, at changing rates. They weren't at a constant rate. We knew the universe was expanding already. We did not know that the universe was expanding at an increasing rate. And so looking at those observations, we found that it was increasing at an increasing rate. Okay, so list the explanations. I said there's really three. So what are the possible explanations? So the first possible explanation is something called the cosmological constant. Okay, something called the cosmological constant. And the cosmological constant is like it's like an acceleration. It's like, what's the acceleration of the universe? Okay, it's like a built-in value for the universe's acceleration. And we've calculated this. We know what it is. So you're probably saying to yourself, well, if we know what it is, why are we having this debate? Don't we know what dark energy is? There's a problem. It's too small. Like way too small. It's like way too small.
That's perfect.
Yeah. So we've calculated it, and it's not anywhere near big enough. So there's some issues with it still, but that's one of the explanations. The other explanation is something called quintessence. Maybe. Anyway, quintessence. And basically quintessence is an energy field that accelerates stuff in it. And the stuff in it is the universe. Okay? There's a problem with this one, too. It's like, okay, like, to an extent, you're just kind of making something up at this point. We're like, hey, there has to be something, so maybe there's this magical field that exists and things accelerate in it. I don't know. That's literally kind of the explanation there.
So could there be more universes in there?
We'll talk about that with the video today. That there might be more than one universe. Yeah. And then the last one is maybe gravity's wrong. Maybe we just don't understand how gravity works. I hope it's this so bad. So bad. I just think it would be really awesome if during our lifetime we came up with another explanation for gravity. Because the first original explanation of gravity was really poor, and then Newton explained how gravity worked, and it was pretty good. And Einstein then explained what gravity was, and it was very good. And I would love if we even further understood gravity a little better. The problem with this one is we don't have an explanation for what else it could be. We don't know what else it could be. We're just maybe gravity is this doesn't work if gravity is what it is. But if gravity is different, then we could maybe have something that would work. Okay. The big thing right now that they're testing with dark energy is they're trying to disprove things. They're trying to disprove theories, and they're trying to improve the cosmological constant. And what's their early conclusions of what they think dark energy is? Well, they think dark energy is most likely what? The cosmological constant.
Or nothing is correct.
Yeah.
Dark energy just doesn't exist.
And honestly, dark matter and dark energy are really good, like, dipping your toe in the water concepts for, like, weird physics things. Because we're going to get into some weird physics things where it's going to be like, what's the explanation? Well, maybe it's this thing, but we don't really know, so we'll go with that. We'll get into some things with quantum physics and particle physics that really talk a lot about, like, some of those weird, some of the weird stuff that we don't really understand. Okay, any questions on dark energy? All right.